Hi, so today we're going to be talking about expected value. And this is another lesson that we didn't really have time to cover in class. However, this one's a little bit simpler than the last one. There's a few things that we need to keep in mind when we're talking about expected value. The formula for expected value is the probability of event 1 happening times the value of event happening plus the probability of event 2 happening times the value of event 2, and so on, for all of your events. One thing, expected value is a really good way of understanding whether you will win or lose money in a scenario. It's kind of a little bit unintuitive, and we'll get into examples as for why that is. And we'll get into, let's just hop into some of the examples of expected value and problems for, I believe it's 7.5, yeah. So this question says that suppose that 10% of the time Danny makes guacamole twice a month, 35% of the time he makes guacamole once a month, and 55% of the time he doesn't make guacamole at all. What is the expected value for the number of times Danny makes guacamole during a month? So we know that 10 out of 100 times he makes guacamole twice. So we can have 2 times 10 over 100. And then the second event happening is that he makes guacamole once a month. So our value will be 1, and it'll be 55 over 100. And the last event is that he doesn't make guacamole at all, which is 0. And the once a month should be 35%. And then the last one is 55 over 100. Now, one thing to keep in mind is that all of these probabilities for each of our events at the very end should add up to 1. Because when we're talking about probability, probability can either be 1, it happens, or 0, it doesn't happen. And in between is like the chances that it happens, basically, like the percentage, the probability that it happens. But we aren't thinking of this in percentage or anything like that. We're thinking about it in 0 and 1. So we want to calculate this, which gives you 11 over 20. Now, what does this mean? Does that mean that he makes guacamole 11 out of 20 times? Not necessarily. The biggest problem that seems to be the case when we're talking about understanding expected value is what this number turns out to be. This is how much guacamole per any given month he makes, which is not intuitive because that's not even an option. You either can make 2 or 1 or 0 guacamoles. You cannot make 11 out of 20 guacamoles. But expected value is basically just telling us the average amount of, like, our average value based on our probabilities. And that will be a little bit more clear as we go through some more examples. I'll skip this one. I'll go over what it would look like. It'd be 1 times 0.33, and then 2 times 0.43, and so on, and then you'd add all of those up. So this one is saying that we need to borrow money for gas. So we ask our mom and our sister, and we can only borrow money from one of them. Before giving you the money, they each say that we need to play a game. Your sister says that she wants you to flip a fair coin, and she will give you $5 for heads and $35 for tails. Your mother says she wants you to spin a spinner with 6 outcomes, numbered 1 through 6 on it. She will give you 6 times the number that the spinner lands on. And we want to determine the expected value of each game and decide which offer we should take. Now, there are 2 different expected value parts that we want. We don't need to combine them all in one. Let's handle our sister's game first. So there is a 1/2 chance that you get a 1 out of 2 chance that you roll a heads, right? And that value is $5. And there is a 1/2 chance that she rolls, that she flips a tails, which will give her $35. And when we calculate that, we should get, our expected value is going to be $20. That's the amount we can expect to win, or like, that's our expected value. Now for the mom's game, she's going to give us 6 times the number that the spinner lands on. And there's there's 6 outcomes, so the probability for each of these is going to be 1 out of 6. So she says for each number, she gives you 6 times that number. So the first, let's say she rolls a 1, that'll give you 6. And then we'll do plus 1/6, because the probability of it rolling a 2 is going to be 1 out of 6. That will give you $12. Plus 1/6, 6 times 3, which is equal to 18. Plus 1/6 times 6 times 4, which is equal to 24. And plus 1/6 for 30, and then plus 1/6 for 36. And when we plug this all into our calculator, we should get our expected value to be 21. So when we look at this, we know that $20 is not an option for us to win in our sister's game, and $21 is not an option for us to win in our mom's game. However, this is just basically saying this is the amount that you on average are going to get. Like if you it's kind of a hard concept to understand, but it's basically just saying this is the average, even though it's not an option. So the expected value for our sister's game is $20, and the expected value for our mom's game is 21. So we want to take our mom's offer, even though even if we didn't think about expected value, to be fair, whatever we get in our mom's game, we get more money. But that it doesn't matter. Because there are some where maybe it starts with 3 instead. So there's a chance to. It really just depends. And sometimes when you're thinking about it, it may make more sense for you logically to choose your sister's game, because you have a chance of getting a lot of money versus a chance of getting varied money. Like you have a higher chance of getting a lot of money versus like varied chance, if that makes sense. So while the expected earnings of your sister's game is about $20 and your mom's game is 21, it still could make more sense for you to choose your sister's. But Hawks wants you to choose the one that is best on the paper. It really just depends though. If the odds on a bet are 47 to 1 against, what is the probability of winning? This doesn't have to do with expected value. It just is one of the questions that you might see. So 47 to 1 against, that means that 47 is the one that is against, and the 1 is 4. That means that there are 48 possibilities, events basically, and one of them is against. So it'd be 1 over 40. I mean, one of them is 4. So 1 over 48 would be our answer. Suppose the probability that an item will go on sale tomorrow is 0.98. And remember, it's not 0.98%. It's just 0.98. What are the odds that the item will be on sale? We want to express it in A to B. So remember when we're talking about probability, it's either 1, it happens, or 0, it doesn't happen. Whoops. So if we add 0.02 to this 98, we'll get 1. So if we think about it like that, because we want our probabilities to add up to 1, we can have our 98 to 2. And it wants that to be in simplest form, which should be 44, wait, hold on. Sorry, 49. I don't know why I said 44. So our answer there would be 49 to 1. That one doesn't disappear. Now it's in simplest form. Hopefully that makes sense. Yeah, I know that it's a newer concept, especially since we weren't able to go over it in class. But if you have a question, please let me know and I'll answer it as soon as possible. Have a good one.